Artificial intelligence, our ability to make predictions using data, is something that is quickly becoming part of our lives. Now, if I were to ask you about the limitations and say I asked you about, can a machine create art, you most likely say no. However, when it comes to studying and making predictions, it goes much further than you might think. If you take an artist for which there's a good source of material of data to study, you could study how that artist makes eyes, how it makes a nose, how it draws a face. And then making a prediction based on that data, you could create new art. You could create new works inspired or in the tradition, in the style of the artist, without the artist having made that work itself. Now, to be more provocative here, I'll take an example of translation. For a long time, diplomacy, especially in places like the United Nations, has been supported by translators, really highly trained people who can support diplomatic missions. However, as you may know, translation has come a long way. About 5 years ago, you could already take a smartphone, put it over a sign that was in a different language, let's say an exit sign, and the phone could make that translation for you. Now, as time has gone on, this has become better and better, and we're now approaching near real time. That is, I'm speaking in English, say, and out the other side is coming out in Japanese or in Spanish or in another language. And so the provocative question here is, should we continue to teach languages? Does it make sense for one of our kids, for example, to spend years and years working hard at trying to master another language if a machine plus algorithm plus data can do that very well? And so I'm being provocative here. Obviously, there's a lot more to learning languages than simply the translation. However, when it comes to thinking about everything that we need to learn in our lives, there's a finite amount of time. And so you might wonder here about the priorities. Should this be something that we devote as much time as we have to in the past, or should we not? So as you can see here, simply in this example of art and the example of translation, we're starting to reassess how we use these tools and how important they are to our everyday work. One of the common questions that is often brought up when it comes to automation, to artificial intelligence, to making predictions using data, is that balance between the human and the machine. And I'll illustrate that a little bit here with an example from the world of tennis, the classic game of tennis. Now, if you follow the sport, you know that there are big Grand Slams around the world, and even if you don't follow it, you might know that it moves from country to country, continent to continent, following the good weather of summer, and they have a good life. Now, when it comes to judging a game, that is, determining whether a ball is in or not, there are a number of judges that support this function within the sport. In a Grand Slam, one of the biggest tournaments around the world, you have up to 11 people that are experts, that have decades of experience, that travel with the tour, supporting these players and making that judgment, that have fine-tuned the skills that they have developed over decades, again, to be able to make those calls. Now, one of the things that you might not know if you are in the sport is that even though you have that tremendous amount of talent, that large number of people, 11 on a tennis court is not that big, players do not agree. And going back through the decades, there are classic meltdowns of players, simply refusing to accept the call that was made, really angry and upset at what had happened, right? Now, 10 years ago or so, technology started to enter the sport. And one of the things that was being tried is, how could we do electronic line calling? How could we use data? How could we use predictive algorithms? How could we use the geometry? How could we use the TV cameras to bring all of that together to be able to make a prediction more accurately than people? And one of the ways that this was integrated, which was really in an elegant way, which is much better than some of the other integrations that have happened in other sports, is that the player could raise their hand. So, the match is ongoing. At any one point where he or she felt that this was not a good line call, he could raise his hand. The challenge immediately started to play back. You got a replay of the previous point, and you could, with much more accuracy, again with the projection, the simulation, the data, the accuracy, determine where the ball had landed. It was a moment of suspense. The audience sort of held its breath, and then you got the result. It was really well done. Now, the sport continued to function in parallel with electronic line calling because it wasn't available everywhere, mostly at the big tournaments. However, when the pandemic hit and there was a need to minimize the number of people participating in one of these big events, the US Open reduced its line calling staff by 4/5. That is only about a fifth of the umpires. And you started to have matches that were fully automated. And here you could see a comparison, a direct comparison between machine and the human. Really the best of the profession, the top experts at the top stage of competition in a Grand Slam versus a fully automated system. And it was quite surprising to see the results. I happened to watch a match by a Canadian player, a top 10 player, and where he challenged during the match, this was one that was staffed with people, 15 times. And the thing that struck me is not the inordinate amount of times he challenged, was that 9 out of those 15 times he was correct. That really surprised me. How could it be that people whose mission in life is to get this right, that are experts, that are at the highest stage, could do it so poorly? And so as a consequence, at the end of this event, once everything was studied and tallied and you could see there the differences and the effectiveness of the technology, the sport moved on. Most of the world now fully understands that the machine, the predictions that are made on the court, the accuracy with which that can be done is simply much better. Now, when it comes to the comparison between human and machine, this is something that we haven't been able to keep up with for a long time, though we may not think about it. For a long time, we haven't been able to compute, meaning do arithmetic, as fast as a machine. However, for a long time, we've sort of thought about that as mechanical, not really something that they could really challenge us on. And what I mean by they is, I mean the machines. Now, in 1997, the chess grandmaster Kasparov, one of the big giants of the field, had a showdown with Blue Gene, a machine built by IBM, a big computer system, with the sole purpose of defeating Kasparov. Well, in 1997, Blue Gene, the machine, clearly beat him. And a lot of people recognize this event as one of the forks in the road, one of the first times that we really got a sense of what a computer could do. Now, one of the things that is least talked about is that the following year, everybody came back for a different type of competition. In this competition, everybody could play against Blue Gene. However, you could bring with you a chess program. And by a chess program, I don't mean a big computer system like IBM's, I meant a laptop. And so on that rematch, if you would, next year, Kasparov with a laptop, remember this is 1997, so it wasn't a high-performance machine, easily beat Blue Gene. But the more surprising thing was that the person that beat the field was an amateur, not a chess expert, but he was very good at using chess programs, and he had 3 of them running on his laptop. And so you can see here that machine on its own can do so much, but expert plus machine is superior. And just somebody who has some knowledge, but is clearly not an expert, but a great use of the programs of the machines, then can beat everybody else. And so many of us look at this and think about it as a great example of human augmentation that is supported by the tools of computing, supported by artificial intelligence, our human skills, our understanding of the domain, plus these tools can really take us quite far. Now, to give you some examples of what I mean by this, think about HoloLens, the virtual reality overlay that Microsoft's technology have given people through this device. This is something that you put on and you immediately see an additional layer of information in your world, much like the old Terminator movies, when the Terminator would look and he could see body temperature, he could see heartbeats, etc. So in this case, you can leverage that additional layer of information for educational purposes, for work, for being able to help somebody through performing some task. And I've seen some of the adaptations that have been made to medical education, and it's really quite something to see. You could take a human body and remove some of the layers, and this is the simulations that have been performed. You could look at simply the skeletal system, the cardiovascular. You could see the functioning heart in a way that you simply couldn't see with a human, or in the way that medicine had been taught for decades or for its entire history. So you can see there the huge advantage and progress that we have made, or that we can make, utilizing these tools. To give you a simpler example, think about how you do navigation using a phone. There we're using data that is being provided by humans, we're using the algorithms that are running on the back end, and we're using our knowledge of the physical world to be able to navigate and to do it more effectively using this tool. Now, to give you an example of something that might not come to mind, I'll give an example from government. Government is not what you think of when you think about artificial intelligence. However, when it comes to the treaties that governments frequently engage in, these are cross-border treaties, these are treaties that are done with allies, with trading partners, and so on, this is quickly digitally transforming. And by that I mean that the enforcement, the monitoring of these treaties is being done by using data, by using Internet of Things devices, by using artificial intelligence. So one of the interesting things about technology is that it doesn't matter where you're in, your world is digitally transforming. And when it comes to government and treaties, the same is true. You're now going to be reliant on data, you're going to be reliant on artificial intelligence. The world is quickly moving to an AI-enabled economy. And what this means is that you need to have the technology, you need to have the talent, the people, and you need to modify your process to be able to leverage this. Now, when it comes to the talent and their use of the technology, this is one place where you will have to compete on a global scale. The resources are so precious that the market is rewarding them at about double the average rate of people who are already at the top of the earning scale when it comes to technology resources. So this is something that you need to get started on right away. You need to be able to attract, you need to be able to maintain. The expectations of technology experts after the pandemic is very different. They want flexibility, they want to be inspired, they do not want to manage, but yet they want to lead, and they want to lead technically. So this is something that now the world recognizes as one of the biggest needs. The biggest advice that I often give to people that are starting out, MIT students, is I tell them, go into cybersecurity or go into artificial intelligence. These are fields that are going to have tremendous opportunities through the next decade. So when it comes to the workplace, the same thing is true as a leader, as a CEO, as one that is leading technology. You need to be able to establish those channels through which you will bring in talent. There is a great level, or a very high level of competition worldwide, and we certainly will integrate that into our workplace. So you need to go through that maturity in developing that technology, of establishing your processes, of establishing new pipelines to be able to bring in that talent. Now, for those of you who are in markets where finding that talent is more challenging, there's a recommendation that I often give. If you have a large workforce, you have a great advantage. Because within that workforce, and what I mean by large is typically about 1,000 employees, within those thousands, you will most likely find somebody that fits that profile, that has that expertise. And then you will find another group as well that is highly motivated to learn. And it turns out that that high motivation is a great indicator of ability to succeed in this field. So out of the gate, you could identify some that you already have. You could identify another group that will most likely pay out and turn out to be just as good as that first group. And then you can complement that with external talent. So as you can see, artificial intelligence is no longer optional. It is something that is going to be required in order for you to respond to customer needs, whether you are in industry or government, when it comes to responding to your citizens, or at any other level of industry or private sector. So as you can see, artificial intelligence is no longer optional. It is something that you're going to need in order to be able to compete. And you need to be able to attract that talent. You need to be able to develop that expertise internally. Now, I make this recommendation as opposed to hiring consultants because that insight, as I have seen with many companies, is much better served if you start with a small group. I saw Walmart grow, for example, from 20 employees, a small group, to a few hundreds. And it's a pattern that I've seen several times through many organizations that I have worked with. So you can identify those resources, get started small, go through those layers of maturity, and grow that expertise internally. Then you can complement with other resources as you might need. But this is certainly part of your digital strategy going forward. It is something that you will need in order to be able to respond to your customers, for government to respond to its citizens, to be able to understand the world through the data that is available.